Okay, so as I told, we will design a mod 6 counter, that is synchronous counter. It comes as part of sequential circuit design and it is called as mod n counter. Today what we are going to do is mod 6 counter. The sequence of the states is already given 0 to 2 to 3 to 6 to 5 to 1. We need not say that the first state is 0 only or 3 only. It can start from anywhere, but it has to go in this sequence. And because it is mod 6 counter, it should have 6 states. And it the states need not be in order the way it was in order in binary counter, which we saw yesterday. The sequential circuit design does not mean that always it has to be in order. So first, you people should understand what is the main truth table. Main truth table you people have to draw. Okay, I am leaving this space for something. If possible, you also leave this space. Okay, let me tell you the main truth table now. Now, in the truth table, we have something called as present state. P underscore S is your present state. Okay, and sequential design, no? So you should have clearly your present and next state. So to start with, I will start with your, I will call it as Q1, Q2, Q3. So if, as you can see in my mod 6 counter, the maximum number what I can see is 6 only. So because I have 6, it means that a 3 variable is enough. Because this is your first problem on sequential circuit design, we are taking a little smaller problem. And in the state, if when you see it is maximum number is 6, so that means we can work with the 3 variable. So that is why my present state will consist of q1, q2, q3. And what is my next state? It will be called as q1 plus, q2 plus, q3 plus. All of you do this with me. Okay, so your next state is q1 plus, q2 plus, q3 plus. Now let me start. If my present state is 0, 0, 0, what is my next state? Quick. If my present state
0,
is,
1, 0.
yes, my present state is 0, 0, 0. So my next state is 2 as per this state diagram. So q1 plus will be 0, 1, 0, right? Now, if my present state is 2, my next state is
0, 1,
3.
1.
Correct. 3. So it is 0, 1, 1. Same way you have to complete your first 2 column. So now my if present state is 3, my next state will be 6. Now if my present state is 6, the next state will be 5. So I am writing 101. If my present state is 5, my next state is 1. So 001. If my present state is 1, my next state is 000. So this completes my two columns of the truth table. Okay, now when I have three variable, I will require three flip-flops also. I will require three flip-flop also. So now what you need to design is flip-flop inputs. Now this is little trivial for you people to understand at once. You also know that one flip-flop, I want design of mod 6 counter using jk flip-flop. Using jk flip-flop, I'm starting with the most difficult flip-flop only. So using jk flip-flop means you know that if I want the change of state from q1 to q1 plus, this can be done using one jk flip-flop. So for the state change from q1 to q1 plus, I will say that I have a flip-flop whose input I am calling as J1 and K1. Okay. Same way, I want Q2 to Q2 plus. So I will use another flip-flop whose input will be called as J2, K2. Then for the third one, Q3 to Q3 plus, I will have my third flip-flop whose input is J3, K3. Okay, so now I will be using three flip-flops for the state change from Q1 to Q1 plus, Q2 to Q2 plus, Q3 to Q3 plus. Now, what you need to understand is you have to concentrate only on the column Q1 and Q1 plus and concentrate in building the truth table for this J1 and K1. If you people have any doubt, you can interrupt and ask in between. Okay. So Q1 to Q1 plus, when the change is happening, this change will be controlled by this J1 and K1. Now, most important, to make this three columns of J1, K1, J2, K2, and J3, K3 is, you should know application table of a clocked JK flip-flop. So I will be using this space now, and all of you should understand how I am making this application table. I am writing application table of JK flip-flop. Now, what do you mean by this application table? You all know that flip-flop changes its states based upon the input. Now, application table means I am writing my output Q to Q plus in left hand side, and I am writing the excitation. I am writing the excitation of JK in right hand side. So I want to ask you people, if a present state is 0 and if next state is also 0, what input JK you would have applied to get 0 from 0? Change of 0 to 0, what input you should have applied? Think and tell me fast. 0 to 0. Before also 0, now also 0. So what state it is in?
0, 1, ma'am, memory state.
0, 1 is memory state, or 0, 0 is memory
Or
state?
0, 0, 0, 0.
Yes. So now there is two possibility. One, memory state. If it is 0, from 0 it remains at 0. Either it can be in memory state or it can be in a reset state also. It can be in a reset state also. See, what you told memory, that is right only. So memory means it is 0 and 0, right? One more possibility is it can be either 0, 0, or it can be, if it is 0, 1, what will happen? Tell me. If it is 0, 1 means it is in reset state. If it is 0, 1 means it is in reset state. Reset state means output will be 0. So it will not bother about Q. Q plus will be 0. My interest is that Q plus should be 0. So either it can be using memory state or it can be using a reset state. So when I have both 0 and 1 here, we replace it with a don't care. Okay, we replace it with a don't care. Now because this was the first one, I had written like this. Second one, I hope you have understood this. Even if it is 0, 0, output will be 0 based on memory condition. If it is 0, 1, it will be 0 based on reset state, right? Now, next, if in Q was 0 and Q plus is 1, what is the possibility?
J is 1.
J is 1 and other possibility? See, J1 means it will be, if I have J1 and 1, J and K both are 1 and 1 means it is a toggle state, right? J and K both 1 and 1 means it is a toggle state. So 0 to 1 it will become, that is one possibility. Second possibility also is there. If it is 1 and 0, then it is a set state. And if it is a set state, then also your next state will be set 1. So this will be 1 and don't care. Okay. Now, next one is 1 to 0. Now, somebody should tell me what will happen, how I can make my output as 0. What two possibilities are there? For everything, two possibilities are only there actually. What will be my two possibilities for making from 1 to 0?
Ma'am,
Yes?
toggle and reset.
Toggle and reset. Very good. You people have understood, I guess, now. So if it is 1 and 1, it is toggle. And if it is 0 and 1, it is reset. So both 1, 1 or 0, 1 will work. So now my J will be don't care and my K will be 1. So, and what is the last one? Last one is 1 and 1. So what will be the possibility?
K is 0.
K is 0. If K is 0 means what? Either I can have a memory state.
Set or
Yeah,
set
right.
state.
I can have 0 and 0, that will be memory state. And if I have 1 and 0, it will be set state. So this will be don't care. Okay. Now, what you have to remember is, 0 to 0 means 0 and don't care. Dash means don't care here. 0 to 1 means 1 and don't care. 1 to 0 means don't care and 1. 1 to 1 is don't care and 0. With this application table, you need to fill these 3 columns. Now, all of you have to see the screen carefully and copy it also. Now, you see, you have to see only Q1 and Q1 plus, because I am giving J1 and K1. I am concentrating on the flip flop, which is taking care of changing the state from Q1 to Q1 plus. So now you should dictate me, what should I write? Q1 is 0, Q1 plus is also 0. So 0 to 0 is what? 0 to 0 is? What should I write here for J1 and K1 using this application table?
0 and X.
Correct. We should write 0 and dash. The first row is being used here. 0 to 0 is 0 and dash. Now next is what? Again 0 to 0. So again copy paste 0 and dash. Next it was 0 to 1. 0 to 1 is what?
1 and dash.
Correct. 1 and dash. Next is what? 1 to 1. So you people should keep your 2 fingers and see properly and then write your answer. Okay. Otherwise students do mistake here. Next one is 1 to 1. What is 1 to 1?
Dash and 0.
Dash and 0. Correct. Now next is 1 to 0. 1 to 0 is what?
Dash and 1.
Dash and 1. Last one is 0 to 0. 0 to 0 is what?
0 and
Again,
dash.
0 and dash.
correct. Again 0. So I hope you people are clear with how did I write this J1 and K1. Now in the same grounds, you should write J2 and K2, observing Q2 and Q2 plus. Okay. So now all of you observe Q2 and Q2 plus and tell me what should I write for J2 and K2 quickly. First one is 0 to 1.
1 and dash.
1
Right.
and dash.
1 and dash. Next,
Dash and 0.
Dash 1.
dash and 0, right?
Yes, ma'am.
0 to 1 is dash and 0. Wait.
Ma'am, again it
1
will
to
dash
1,
and
sorry,
0.
sorry. 1 to 1 is dash and 0, right? Again we have 1 to 1. So again dash and 0.
0 to 0.
Ma'am, you have dash and
0
1
and
now.
dash.
Dash and 1.
Yes, are you able to see? Okay, are you able to see now? The connection was lost in between.
Yes, ma'am.
Okay, so I am completing the table. Okay, you can check whether I have completed it correctly or not. So I have completed the table based on the application table which I have explained you just now. So like this, we complete our excitation table. The name given to this is called as excitation table. Excitation table, and a good excitation table for a synchronous mod 6 counter. So this is called as excitation table. Okay, and a good amount of marks is always allotted for this. Okay, so now this makes your flip-flop input. Now what is the next step? I will be changing the sheet, so all of you should copy this part quickly if you have not done it yourself. I will be changing the table. Now next we are supposed to write equations. Now how do we write equation is, you know that your J1, K1, J2, K2, J3, K3, these are the flip-flop input which should come in this way only. So when we have, you all know na, that when we make K-map, we make K-map with respect to input. So now I have how many excitation input I have? I have 6 excitation input, J1, J2, K2, J3, K3. So when I have this 6 excitation input, so this becomes my output for the K maps. And what is my input? Input will be my present state. Okay. Now I am changing the changing the page, and you people should understand what is the next step now. Now the next step is, I need to write the equation for these 6 excitation inputs. So equation will be J1, K1, J2, K2, J3, K3. These are my excitation input, and this is function of what? Can somebody tell me? It is function of what? What makes the change in J1, J2, J3, K1, K2, K3? It is always your present state. And what is the present state now? Present state is Q1, Q2, Q3. Okay. So now you are supposed to make 6 K map. You are supposed to make 6 K map, and your K map will be made based on the excitation table which you have made just now. So my first, I will be
Ma'am, doubt,
making,
ma'am.
now tell me.
Why will it be depending on the present state? Shouldn't it depend on the next state?
See, present, based upon your present state, only your next state is decided. So next state becomes
Okay,
the
okay.
output of the flip-flop.
Yes, ma'am, got it, ma'am.
Okay. Present state only decides my next state. So input will be present state. Okay. Now,
Yes,
your J1, for J1, what I have to write? It is Q1, Q2, Q3, right? Now, your K map will be something little different now. Now you people are in habit of seeing the K map in little different form. Now let me go to the previous page, and all of you can see now. I am writing for J1. So you have to concentrate on this column only. Now in this column, how many ones you can see? You can see only one, right? So this one is one for which one? This one is one for 3. Can you see this? For present state 3, my J1 is 1. And it is 0 for which all? It is 0 for 0, 2 and 1. 0, 2 and 1. So now let me check now. I have to, of course, write the each cell number so that it is easy for you to understand. So I'm writing here, it is 0, 1, 2, 3, 4, 5, 6, 7. So what you saw in the previous page, it was, you people have your reference excitation table with you, na? So you see there, it was 0 for 0 and 1, and it was 0 for 0, 1 and what else? 1 and 2, right? 0, 1 and 2. And it was 1 only for one case, that was 3, right? And it was don't care for which all? It was don't care for 6 and 5. Now what about 4 and 7? 4 and 7 was never there in my table only. So the numbers or the states which are not there in the table, for those states also we put a don't care only. So can you see how easy it is to make this K map? This K map of Q1, Q2, Q3 is made with this J1 is made with respect to this present state Q1, Q2, Q3. So wherever J1 was 1 for 3 and 0 is copied to that K map. It is copied to that K map and I am able to make this. So can somebody tell me what will be the grouping? Only one grouping possible, that is this, right? Our headache is to make grouping of 1. We need not bother about 0 or don't care. So this is what? This becomes J1 is Q2, Q3. Is it clear to all of you? How did I make this? If any doubt, you please let me know. Now I want different students to do different J2 for K1, K2, K3. So I will ask randomly any one of you. So USN 1 to 10 can do K1. USN 1 to 10 can do K1. USN 11 to 20 can do J2. USN 21 to 30 K2. 31 to 40 K3, sorry, J3, and 41 to 50 K3. Okay, so all of you do it. I will ask randomly and you need to answer me. Okay, so quickly make for J1 and all the J's and all the K's. If somebody has completed, can interrupt and give me the answer also. I will be happy if somebody gives me answer before me asking. J2, K2, J3, K3. So you can see all J's are in one column, all K's are in next column. Okay. So because so many don't cares are there, it will be quick to get the answer.
K1
Yes.
equals to Q2 bar.
Q1 is equal, K1 is equal to Q2 bar. So you should also help me telling which are one, which are don't care.
0, 1, 3, 2 all are don't cares. And
All
then,
are don't cares.
yes, ma'am. And then 4 is also don't care, 7 is also don't care.
Okay.
5 is 1 and 6 is 0.
5 is 1 and 6 is 0. So
Yes,
what
ma'am.
grouping you have done?
Ma'am, 0, 1, 4, 5. A quadrant.
Okay. As we know that grouping should be as big as possible so that our equation should be simple. Thank you very much. Very good. So K1 is Q2 bar. He is right. Okay. Now we got it. Now others also can give answer like this. Other USNs.
Ma'am, J2 is Q3 bar.
J2 is Q3 bar.
Yes, ma'am.
Okay. Wait, I will put it. You should tell me which one is ones. I hope others are also understanding what he is telling. For J2, okay, let me go to J2 column. J2, when you see J2, it is 1 for 0, right?
Yes, ma'am. It's only 1 for 0. It is 0 for 1 and 5.
Okay, 0 for 1 and 5. So we will copy that. So it is 1 for 0 and 0 for 1 and 5. And
Yes,
rest
ma'am.
all are don't cares.
Don't cares.
Right.
So the grouping will be 0, 4, 2 and 6.
Correct. We should do grouping in this fashion so that my expression is less. So it is folding the K map folding the K map, and it is 0, 4, 2 and 6 together, and it becomes J2 equal to Q3 bar. I hope you people remember, others remember how I am writing Q3 bar, because this is 0, 0, 0, 1, 1, 1, 1, 0 and 0 and 1. So what you see is Q1 is changing and Q2 is also changing from 0 to 1 in the group. Only Q3 is 0 here and here. So Q3 is not changing. So Q3 is 0. So it becomes J2 equal to Q3 bar.
Yes, ma'am. K2 is K2
K2
equals
is
to K1. Q1.
Q1. K2 is equal to Q1. Okay.
Yes, ma'am.
So
It
let
is 1
me...
at 6.
1 at?
6.
Okay. It is 1 at 6.
And 0 at 2 and 3.
0 at 2 and 3.
And rest all I don't care.
Rest all are don't care. So as we can
4,
see...
5, 7, 6.
Okay. Good.
Okay.
So it is... We have to get a row group. We are getting a row group like this. And that is why K2 is equal to Q1, right? Yes. Very good. Thank you very much. Next,
Ma'am, J3 is Q2.
J3 is Q2. Okay, you should tell me ones and zeros also.
Yes, ma'am. It is a 0 at 0.
Okay, let me see here to help other student also. J3, when you see column of J3, 0 is at 0.
0.
Hmm.
And it's 1 at 2 and 6.
1 at 2 and 6, rest all don't care. So,
Don't care.
yeah, right. So, it is 0 at 0 and 1
1 at 2
for
and 6.
2 and 6. Rest all are don't care. So,
So
again we can have a group of 4. We can have
3,
a
2,
group
7,
of...
6, ma'am.
Right, one more is don't care. So we have a group of 4, and this group of 4, again you people should see how we are doing is, you can see what all is changing. You can see that Q3 is changing, right? And Q1 is also changing. What is not changing is only Q2. So J3 is equal to Q2. Yes, what about the last one?
Ma'am, it's Q1 bar.
Okay, it is Q1 bar. Okay, let me write it.
It
Others are
is
also understanding, no? All others are understanding?
Yes, ma'am.
Okay, good. Now tell me. Good. If you are understanding, I am very happy. Now tell me, 1 for which one?
ma'am, 1 for 1 and 3.
1 and 3 is 1.
5 is 0. Rest all
5
don't
is
care.
0. Rest all don't care. Okay.
So 1, 2, 0, 1, 2, 2, 3 is the group.
Okay. So we are able to get a row group. We are able to get a row group like this. Okay. This is 0 and 1. So we can see only Q1 bar is not changing. Only Q1 bar is not changing. So you got your equations, right? You got your equations. Now I want to show you how to make the circuit out of it. Okay. Final circuit will also carry 2 to 3 marks. So it is very, very important to make the circuit. Now I will change the page to make the circuit. All of you should copy these equations carefully. J1, J2, J3, K1, K2, K3. Then we will make our circuit, the final logic diagram of synchronous mod 6 counter. So now I am changing the sheet, okay, and we will make the final circuit. So this will complete your this question, okay. Now let us go to the next page, that is final logic diagram. Final logic diagram of mod 6 counter, okay. Final logic diagram of mod 6 counter. So now what you have to do is, you should make it very neat and clean, and a examiner generally will see your final circuit and they will see your equations, okay. So how you have to make it, because it is 3 flip flop, you will have to make 3 boxes like this. These boxes are nothing but your JK flip flop, okay. Your J and K are the 2 input. It is a generalized diagram of JK flip flop. So you will have your Q and Q bar shown here, okay. Q and Q bar shown here like this. So you will have to make for all the three flip-flop like this. Next, because it is a synchronous counter, you should make your clock. You should make your clock C for clock. That is a generalized variable given. And this clock all are connected together. Show the connection with the heavy dot. All the three clocks are connected together and we call it as count pulses. Based upon one clock period of the clock cycle, your state changes. So we call it as count pulses. Now you will call this first one as Q1, Q2 and Q3. And this Q1, Q2, Q3 only is your output. Okay. Now comes the connection. Now comes the connection. Now you people have your equation there in front of you. I will show you how to do the connection. What is J1? J1 was Q2, Q3, right? Let us again see what is J1. J1 is Q2, Q3. So I should give input of J1 as Q2, Q3. So how will I do it? I will show you. J1 input is an ANDed version of Q2 and Q3. So from where I will get Q2 and Q3? Q2 and Q3 are given here. So your Q2 will become one input of your AND gate and Q3 will become your second input of AND gate. This is your J1 connection done and you should write here J1. Okay. JK here you should not write. This is your flip-flop diagram. So J1 comes here. You got your J1. So now what is K1? K1 was Q2 bar. So what you will do? Tell me. What you will do for Q2 bar? You have a ready-made Q2 bar available with you, right?
Yes, ma'am.
So we will directly connect. You all know that this is Q2 and this is Q2 bar. So directly I will bring it and I will connect it with the K1. I will connect it with this K1. So because Q2 bar is readily available. Next, what was your J2? J2 was your Q3 bar. Remember? J2 was your Q3 bar. So we will make J2 equal to Q3 bar. So J2 is here and Q3 bar is available here. So you have to see that your diagram is neat and clean. You will not have these many colors in your exam. I have as of now, I am using it properly. But you have to make your diagram very neat and clean. So this is your J2 which is equal to Q3 bar as per your equation. Now what is your K2? Somebody tell me what is your K2? K2
Q1,
is,
ma'am.
yeah, K2 is Q1. Q1 is also available with me. So what I will do, I will again change my pen color and show you. K2 is Q1. So Q1 is also readily available. I will bring it from this direction. Okay. So that confusion does not happen. So this is my K2. So K2 connection done. Same way I will be doing J3 and K3 connection. J3 is what? J3 is equal to Q2. J3 is equal to Q2. So from where shall I bring? Okay, already Q2 has gone for this AND gate. Remember? This Q2 has gone for this AND gate. I will take from there only. We should make the connection proper. So Q2 will come and connect to this J3. J3 is equal to Q2 as per our equation. So directly I brought from the input of AND gate. Next, what is K3? K3 is Q1 bar. Anyway, Q1 bar is not readily available, or is it available? No, it is not available. So K3 bar is not readily available. I will have to bring it directly from the output. So which color to use? Okay. So I have K3 as Q1 bar. So I am directly bringing from there. And please see to it that your connections does not become untidy. So this is your K3. This is your K3. Now see, it will be difficult for anybody to check this connection. So it is always keep your equation ready with you so that examiner can understand that you have done it right. So now this is your final answer. So this is final logic diagram of mod 6 counter, which is taught today, starting with your state diagram, your present state, next state, and flip-flop input excitation table. And this excitation table you could make using this application table. And here I taught you this application table. But in general, you should remember this, that 0 to 0 is 0 dash, 0 to 1 is 1 dash. If it is there in your memory, it is easy for you to do it quickly. And if you don't do this quickly, your time utilization is less in the exam. After that, what did we do? We made this K map using these truth table for 6 J1, J2, J3, K1, K2, K3, 6 K map came and we got this equation. And then we made this circuit with our 3 flip-flop and the connections from output to input, and based upon those logic functions, we made it. Okay. Now, if you have any doubt in this, you should ask me.